So am I audible to you all? Good morning everyone. Am I audible? Good morning everyone. Am I audible? So am I audible to you all? Good morning everyone. So hello everyone. Am I audible to you all? Good morning Komal. Am I audible? Okay. So in the last class we have seen the divergence theorem and we had derived that also. So now in this session we are going to discuss Coulomb's law. So I think everybody is aware what is Coulomb's law. So if I wanted to ask you, can you please tell me how do you define Coulomb's law? Anyone, if anybody is interested in giving the answer. So because I wanted to take an overview that how much you know about Coulomb's law because you have already studied in your class 10th and class 12th. So because after this class, this Coulomb's law will be very simple for you. So before that, I wanted an overview. What you understand by the term Coulomb's law? What is Coulomb's law? How will you define that? Can anyone answer this? So nobody is interested in giving answer. So Amisha, how will you define Coulomb's law? Amisha? Aditi, how will you define Coulomb's law? Aditi, am I audible? Am I audible to you, Aditi?
Yes, sir.
So how will you define Coulomb's law? What is Coulomb's law?
सर ना मतलब दो इलेक्ट्रिक बॉडी को जब है ना एक दूसरे के टच में लाते हैं तो उनमें जो अट्रैक्शन होता है उससे मतलब जनरेट होता है.
अच्छा, बोल सकते हैं, ऐसा बोल सकते हैं, लेकिन परफेक्ट आंसर नहीं है. प्रतिभा, आप बताइए क्या होता है कूलम्स लॉ? आप क्या समझती हैं कूलम्स लॉ से? प्रतिभा?
सर दो इलेक्ट्रिक चार्ज को पे जो चार्ज प्रोड्यूस होता है उसमें.
अच्छा, ठीक है. तो नाउ इट्स माय टर्न टू आंसर. So see, I'll give one definition and according to that definition I will make you to understand, and after this definition you will find that this you will never forget this. ये मेरा मतलब ऐसा समझिए, इसके बाद आप नहीं भूलिएगा. ये मैं आपको बोलूँ. So पहले आप कॉपी पेन निकालिए और लिखिए definition Coulomb's law. What is Coulomb's law? How will you define Coulomb's law? So basically Coulomb's law is direction of forces. जया ने क्या लिखा है देखते हैं. Jaya has written two charges light at a distance r, then division of multiplication of both the charges and the square root of r with constant equal to force. जया लिखा सही है पर समझ में नहीं आ रहा है. तो देख के लिखा है क्या जया? So I'll define that Coulomb's law, and after this definition you will not forget that. I'll prove my statement. See, Coulomb's law basically is, so if you have copy and pen, write that direction of forces acting on charges. So basically you don't need to write this. If you wanted to define force acting between two charges, force acting between two charges is directly proportional. So if you have copy pen, please write there. Is directly proportional to charges and inversely proportional to square of difference between them. So you don't need to be scared by this long definition. So that will, sorry, force acting between two charges is directly proportional to directly. So this is the definition. Force acting between two charges is directly proportional to charges and inversely proportional to square of difference between them. So see, I'll make this definition very simple. So what they are saying that force acting between two charges is directly proportional to. Suppose we have two charges. We have two charges. That is one is Q1 and one is Q2. So based on that statement also now I will prove this what is Coulomb's law. So what is written there? Force acting between two charges is directly proportional to charges and inversely proportional to square of difference between them. So suppose the distance between them Q1 and Q2 is R. So what we are considering, the distance between this Q1 and Q2 is R. Then in the first line it is written that force acting between two charges is directly proportional to charges. So we'll stop here. So what is telling that? That force acting between two charges, that is Q1 and Q2, is directly proportional to force. The meaning of this statement is that F is directly proportional to Q1 and Q2. Now, and inversely proportional to square of difference between them. So inversely proportional means I need to divide it. So what I will do? Inversely proportional to square of difference between them. So what is the difference between them? They are separated by a distance R. So if they are separated by a distance R, this is what? This is inversely proportional to F. So this is what your Coulomb's law is. I'll open this bracket after this. So you don't need to by heart the statement. If somebody will ask you how we will define Coulomb's law after asking, you need to answer this like this. So based on if you will remember this, you can write the definition. So what it is written there, that two charges are there, Q1 and Q2, and it is separated by a distance R. And both Q1 and Q2 is directly proportional to force, and the R, which is the square of the R is inversely proportional to force. That is what Coulomb's law is. So when you will open this bracket, what you will get? So if I open this directly proportional, I'll get here 4 pi epsilon naught Q1 Q2 by R square. So that is what Coulomb's law is. So if formula is clear with you, you can define it very easily. And since you are an electronic student, you must be knowing this Coulomb's law, because anybody can ask you, not only in interview or in any, if your younger brother or sister, anybody can ask you, so what is Coulomb's law? So based on this definition, you can make them understand what is Coulomb's law. So basically what it is. So force is directly proportional to two charges and the square of, and it is separated by a distance R, and that R is inversely proportional to that force. So I think everybody is clear with the Coulomb's law. If anybody is having doubt in the definition and the formula, I'll try to say one more time. So if you are, so I think you are clear. Now you can say what is Coulomb's law. You don't need to by heart this definition. So now you are clear with the Coulomb's law. So if anybody has doubt, you can stop me in between and you can ask me. That is, so should I move on? Should I go forward? So please give ऐसे एक तरफा मत रहिए, दोनों तरफ से बात होता रहेगा तो अच्छा रहेगा. So please, no doubt. So everybody try to understand that. So now I will explain the two cases. The polarity of two charges are same, and if the polarity of the charges are different, means suppose if you are talking about Q1 and Q2. So now what I am going to say, now I'll talk about if the polarity of these two charges, if it will be positive in first case, and if in the second case if it is negative, means Q1 and Q2 is negative for the second case, and for the first case I am considering that Q1 and Q2 is positive. So these two cases I am considering, and now based on these two cases, now I will tell you. So let's remove this. So I had given the definition of Coulomb's law. If you have not written, you can write it one more time, that force acting between two charges is directly proportional to charges and inversely proportional to square between them. So that is what F is directly proportional to Q1 and Q2, and F is inversely proportional to the distance between distance of that. So what we have defined that the formula which we have defined, that F is equal to 1 by 4 pi epsilon naught Q1 by Q2 upon R square. This is the formula of Coulomb's law, and based on this formula, we are going to solve problem. So let's suppose I am considering the first case. In the first case, both the charges are having same polarity. Means both charges are having same polarity. Let's suppose I am considering this. So if I consider this, that so if Q1 and Q2 are having, suppose if Q1 and Q2 have both positive or it has both negative, whatever you can consider. So what I will write, that Q1 and Q2 is greater than 0. So from there, what I will write. So if suppose this is our Q1 and this is Q2 and it is separated by a distance R. So if both Q1 and Q2 greater than 0, so force acting on Q1 will be on opposite direction. Force acting on Q2 will be on opposite direction. So what I will say is that Q1 is repulsive to Q2. So what I will say, Q1 is because the direction of F is in this, and so if both are having Q1 and Q2 is greater than 0, if I consider this, so what I will say from what I will say, that this both F1 and F2 are repulsive to each other. Means F1, if I consider this F1 and if I consider this F2, so from this what I will say, that F1 and F2 are repulsive to each other because their directions are opposite. So they will repel each other. If both Q1 and Q2 greater than 0, if it will be in the same direction, if it will be having the same polarity, if plus plus will be there, then what will happen? So it will be, so both plus will be there or both minus will be there, then what the result we will get? We get the repulsive result. Means direction of F1 will be in this side and direction of F2 will be this side, because we are considering the same charges. That is Q1, Q2 greater than 0, or we are considering Q1 as positive, Q2 as positive, or Q1 as negative, Q2 as negative. So in this case, if in this case we are considering that, then what we will get, that F1 and F2 are both are repulsive in nature. This is our first case. So I'm just making you to I was saying this because I needed in the future Coulomb's law. So based on this, we will apply Coulomb's law on the questions, and based on this we will solve problem. And one question is there. One question they had asked in your RTU paper. So we'll solve that only. That also. So you just need to be concentrated. You will get this very easily. So this is our first case. So now I'll consider the second case. So for second case, suppose both charges are unlike. So in case 2, what I am saying is, in case 2, if both charges are unlike polarity, means that one is positive, or one is negative, or one is negative, one is positive. So in that case, what we will consider, that in this case we will consider that Q1, Q2 less than 0. So if this will be the case, suppose this is our Q1, Q2, and this is separated by our distance R. So what we will get, that if Q1 and Q2 is less than 0, so in this case what we will get, that both F is of direction of F will be attractive. Means it will be in this direction only. It will be an attractive force. F1 is this side, F2 is this side. So both F1 and F2 is attractive in nature. So first case, if we consider the same polarity, in that case, what we are getting that both F1 and F2 are repulsive in nature, and if we are considering that Q1 and Q2 of unlike other polarity, means if suppose we are getting that Q1 is positive, Q2 is negative, or Q1 is negative, Q2 is positive, in that case, what we are getting that F1 and Q1 and Q2, F1 and F2 is in the attractive position. So these are the two cases in the Coulomb's law. So now let us try to understand the direction of this, means in which direction these charges are moving. So after this will be more clear to you. So let's suppose based on the pointing vector, we are going to understand the last thing we are going to understand based on the direction in which these charges are moving. So I hope these two cases are clear with you. So now let us understand based on the direction. So then it will be more clear to you. These are the two cases which I had defined. First of all, I have told you. So till now we had understand what is Coulomb's law, how we will define Coulomb's law, what are the two cases in that. So till now we had studied that. Now based on the direction we are going to study. So let's suppose if you have two charges. So I'll try to. So let's suppose based on direction I'll try to make you understand. So let's suppose if you have two charges here, one is Q1 and one is other is Q2. And Q1 is indicated by position vector R1. So it is indicated by, suppose it is our position vector R1. This is our position vector R1, and it is indicated by position vector R2. And this is Q2, and Q2 is indicated by position vector R2. Suppose if we are indicating this Q2 by position vector R2, and suppose so then there will be, so in this case direction of forces will be in this side. In this case, direction of forces will be that side. So this is, so here Q1 and Q2 have same polarity. So let's suppose Q1 and Q2 have same polarity. So for this case, then there will be repulsive force, and that to calculate the repulsive force by direction. So if it is will be having the same polarity, what I had given you the case that Q1 and Q2 should be greater than 0. We are talking about this case, which I had earlier told you in the first case only. So based on the direction, we are going to find out the value of F. So then there will be repulsive force, as we are already knowing that to calculate the repulsive force by direction. How do we calculate the repulsive force by direction? So what I will write here. So see, F1 equal to 1 by 4 pi epsilon naught Q1 Q2 by R square, and it will be multiplied by R1 vector. So because why we are multiplying by R1 vector, by because Q1 is indicated by position R1 only. So based on the direction, now we are going to calculate F1 value. So now I am multiplying this by R1 vector because Q1 is denoted indicated by the position vector R1. So how I will calculate R1? So the force acting on the charge Q1 will be F1, which is in this direction, and R1 is in this direction. So how to get the value of R1? So to calculate the value of R1, we are already knowing that R1 equal to R vector upon magnitude of R. So basically this is a unit vector which I am talking about. So everybody is aware that how to calculate unit vector. So how we will calculate that unit vector, that R1 equal to R vector upon R of the magnitude vector. So what will be the R vector? R vector will be the R1 minus R2. Why I have done this? Because see, the direction of R1 is this side, and R2 direction, if you will see in the paper, R2 direction will be in the same side. So both direction are in the same side. So upper minus lower, R1 minus R2. Whatever you are calculating, you need to subtract those from higher minus lower. So higher will be R1 other will be R2. So I have subtracted R1 minus R1. So what I will get here? 1 by 4 pi epsilon naught Q1 Q2 by R square, and instead of this R vector, what I will substitute here? So I will substitute here R1 minus R2 upon R. After that, what I will get? 1 by 4 pi epsilon naught Q1 Q2 RQ R1 minus R2 vector. So based on the direction, I have calculated the value of force. So if anybody is having any doubt, I'll explain you one more time. Let's suppose this is a bit complicated. It is looking a bit complicated to your side. So I'll draw the figure one more time and I'll try to make you understand one more time. So based on the, now what we are going to do, based on the direction, we are going to calculate those vectors. So suppose Q1 is in this direction, Q2 is in this direction, and force acting on Q1 is F1, force acting on Q2 is F2. The same force I'm talking about, F2, direction will be this side, and Q1 is indicated by the position vector R1. So this is the position vector R1 from which Q1 is indicated, and Q2 is indicated by the position vector R2. This is Q2 vector and we are indicating position vector R2. So here Q1 and Q2 are having same polarity. So we are talking about that Q1 and Q2 are having same polarity, means same sign we are talking about. So same polarity means Q1, Q2 greater than 0. So if it is having the same polarity as I have discussed in the case 1, that there will be a repulsive force, then now how to calculate the repulsive force? By now we need to calculate the repulsive force by direction. So based on that direction, we are already aware of the fact that formula for F1 equal to 1 by 4 pi epsilon naught Q1 Q2 upon R square and R1 vector, because we are applying this on Q1. So Q1 is indicated by R1 vector. So I have multiplied this R1 vector here. So now how to calculate this R1 vector? So basically this is unit position vector. Why I am telling you unit position vector? Because position of Q1 is indicated by R1. So what we will call it as unit position vector. So now what will be value of R1? R1 vector will be R vector upon magnitude of R. So vector of R will be R1 minus R2, higher minus lower. What will get the vector of R? Vector of R will be R1 minus R2. So so suppose if you had applied on the R2, so what we have written there? R2 minus R1. So in this case, I am applying on R1. So what I will write here? R1 minus R2 by magnitude of R. So now you need to substitute this value here. So after substitution, what you will get? You will get here 1 by 4 pi epsilon naught Q1 Q2 by RQ into R vector. And we are knowing that R vector is equal to R1 minus R2. So this is the first case which I am talking, and in the second case, if you will apply this position vector on, suppose if you are applying on Q2, so what you will write here? 1 by 4 pi epsilon naught Q1 Q2 by RQ into R2 minus R1. If you are applying on the Q2 vector, so based on the position vector, you can calculate it like that. So in this, if you are having any doubt, you can ask, or we are going to solve a problem based on that. So if you are having any doubt, please ask in this. So since Q1 is associated with R1, so I have done R1 minus R2, and Q2 is associated with R2, so I have done R2 minus R1. So based on the direction, we can calculate the value of F1 and F2. So in this, if you are having any kind of doubt, please ask me. Should I move on? Should I solve a problem? Okay, so we'll move on. So let's suppose how the question will be asked. So let's suppose the value of Q1 will be given as 1 microcoulomb, Q2 will be given as 2 microcoulomb, and it is separated by a distance r, and distance r is given as 1, and they are asking you to force acting on Q1. So if the question will be written like this, that force is acting on Q1. How much force is acting on Q1? And both are having the same polarity, so it will be having a repulsive force. So if these two are, and position vector is not given, so we'll calculate only magnitude. So if suppose position vector is not given, that is r vector is not given, so in this case we'll calculate only magnitude. We need to calculate only magnitude for that. So if the question is that how much force is acting on Q1, so we'll solve this problem. We'll try to solve this problem. So suppose that this is our problem. Q1 is given as 1 microcoulomb, Q2 is given as 2 microcoulomb, and distance between them is r. So what I will do, I'll just substitute the formula, and after substituting the formula, this is the simple question which they will ask. So what you will do, you will substitute the formula. So what is the 1/4 pi epsilon naught Q1 Q2 by r square. So value of this will be, if you had been already knowing that 9 10 to the power 9, 1 microcoulomb is 10 to the power minus 6, 2 microcoulomb is 2 into 10 to the power minus 6, and distance of r will be 1 square. So when you will solve this, you will get that force will be 18 into 10 to the power minus 3 Newton. So this is the simple question which they will ask. Now I'll give one tough question, so which will come into your paper. So this question, please write. Now I'm going to give one question to you, so please write that. So this is the simple question. They will ask for one or 2 marks. So in that case, Q1 value will be given, Q2 value will be given, and the distance will be given, and you need to calculate force acting on Q1. So if the r vector is not given, you need to calculate only the magnitude. So you'll apply this simple formula and you'll calculate force here. So after calculating force here, you will get 18 into 10 to the power minus 3 Newton. So this is the easiest problem which they will give, and one problem will be there based on the Coulomb's law. So now one more problem I'm going to give you. So please try to understand that. So now the problem which I'm going to give you, if you'll understand that, then Coulomb's law will be over. So that will be the complicated problem, and you need to apply the brain only. So I'll give the hint and all, and you need to solve it as a homework, and next class we'll discuss it. So let's write the problem. And this problem is there in your RTU paper. So let's suppose the problem was like that. If 2, and it was having of 8 marks. So if you are clear with the basic, so you can easily solve this kind of problem. So if 2 charges 1 microcoulomb and 2 microcoulomb are separated by 1 meter, then at what distance from 1 microcoulomb charge force on charge So this was the problem which came into your paper, and this was carrying 8 marks. So see, some simple problem is there. It is our having. So you'll by looking at that, you'll see it is so simple, and they have given it for 8 marks. So it is not that simple. So what they are asking, that if 2 charges are of 1 coulomb and 2 coulomb are separated by a distance 1 meter. So first of all, in any question we need to draw the figure for that. So we'll draw the figure for that. So 2 charges are there of 1 coulomb charge and 2 coulomb charge, and they are separated by a distance of 1 meter. And what are they are asking? Then what distance from 1 coulomb charge force on charge Q will be 0. So basically they are asking that at what distance from 1 coulomb charge, so force will be 0. So suppose where the force will be 0. So first of all, we need to understand that what location that we will place the Q, so that force on Q will be 0. So what they are asking, that where will be the location of Q that the force will be 0. Suppose, so on this axis it is not possible. So in this axis, force will be not zero. So we need to draw an axis here. So let's suppose I'm drawing axis here. This is of 1 coulomb. This is of 1 coulomb. This is of 2 coulomb. So they are asking that where you should place Q. Either you place Q here, or you place Q in between 1 or 2 coulomb, or you place Q after 2 coulombs. So where you will place Q, that force acting will be 0. So this is the question. So now you need to find that where you will place this Q, that Q which we wanted to find. So where you will place that Q, so that the force will be 0. Either you will place this Q before in this region, that is 1 coulomb region, or you will place the Q in between 1 coulomb and 2 coulomb, or you will place the Q after 2 coulomb. So you need to find this, that where you are going to place Q, that force acting on this will be 0. So how much distance will be there from 1 coulomb? So you have understand the question, what the question was asking here. So so this is a homework for you. So this question and one more question we are going to solve in the next class. So you please try you please give your effort how much you can try. So because this question considered 8 marks, so basically three cases will be there. So based on that case, you needed to solve the problem. So I'll make things much simple. So you cannot place here. So let me give some hint. And you cannot place here. Why not here? I'll tell you. Because if you'll place Q over here, so there will be repulsive force. Because of this will be in this direction. In this direction. So it will not possible, because there will be repulsive force and this both will become 0. So this direction will be not possible. In this direction will be not possible. So if you consider this, things will be not happen. Because of this, there will be forces will be added there. So you need to place in between. So suppose like that, I have placed Q here. So distance of this will be X. Distance of this from 2 coulomb will be 1 minus X. So this I have given you. So if you place here, what it will be, what you will get here, that what you needed to do, that F1 should be equal to F2. These hint I have given you. Based on that hint, you need to solve this problem. And if anybody will solve, then I'll make sure that he or she has got the Coulomb's law. So like this, one more problem we'll try to solve in the next class, that is on Thursday. This is a homework for you. Please give it a try, because this simple question will be there in your paper, and you'll be like that. आपको ऐसा लगेगा कि हमको आता है पर लगा नहीं पा रहे. So please give your effort how much you can, and please try to solve this problem and come up with the idea that why we can't put it here and why we can't put it here. Why we needed to put it in that side. So I'll ask it from your side. When one more question we will do on this Coulomb's law, and we'll continue and we'll complete this. So based on this Coulomb's law, one question will be there always. So if you solve this, you can solve any type of problem. So try to understand what problem is asking. So if you are having any doubt in this, please ask me. So either or we will continue in the next class. I hope everybody has understand the question. So try to solve it from your side also. So if I'll solve this, it will be completed in 2 minutes. So I don't want to do from myself. I wanted so that you can try from your side. So if you are having any doubt in this Coulomb's law, please ask me. Any kind of doubt if you have not understand. अगर ऐसा कुछ भी समझ में नहीं आया तो आप पूछ सकते हैं इसमें. Okay, so please try to solve this, and we will meet in the next class. This will be the homework, and I will definitely ask this question, because this is most important question, and one more question is there which has been asked in your paper. So 2 problems we will solve on Coulomb's law, and next class we will complete the Coulomb's law. So after this, we will apply the applications of Coulomb's law in EMFT. So I am teaching you this because these applications are there. So as we have already seen that in Maxwell equation, divergence theorem, Stokes theorem, all these were needed. So if you are clear with that fact, you can easily derive Maxwell theorem. So if Coulomb's law I am teaching you, it will be applicable somewhere, and questions are there. So they are asking question based on the Coulomb's law in your paper. So it's all for today. We'll meet on next schedule. Thank you everyone. We'll meet on next schedule. So actually the power was cut, so we lost the lecture in between. So I hope you have got today's lecture in a you have understand what I wanted to teach you. So I have told you some assignment. You needed to do that assignment, and we will try to continue our class in the next schedule. So we have seen all the topics related to flux density and all, and I hope everybody is clear. So is there any doubt? If you are facing any kind of difficulties, please ask me. So is there any doubt with you? So, and one more thing I wanted to tell you that we will discuss our paper in the next schedule, the midterm paper which is assigned, which has happened. So for biomedical and EM waves, so we will try to discuss that paper in the coming schedule, that is on Thursday. So we will discuss that paper on Thursday, and after discussing, so some numericals were there, so there will be some problem with some people that they had not solved those numericals. So I will thoroughly discuss that, and I think biomedical paper was simple, so it was theoretical. So some theoretical question was there. So I saw the paper. Everybody has given some answers. So let's see. We will discuss it on coming Thursday, and that is all for today. We will meet in the next schedule. Thank you, everyone.